Problem 4-30, we're taking a look at these two graphs. The first question wants us to write an equation using points A and B. Since A and B are where the two graphs intersect each other, we're looking at when these two functions here are equal. So my two functions would be that are equal 1/2 times x minus 2 cubed plus 1, and where that equals 2x squared minus 6x minus 3. Looking at the equations, since there is no y values, make that look a little nicer. Since there are no y values, we're only taking a look at the x values of these coordinates. So you can take a look over here, there is no y involved. So I only care about the x values. So when I look at point A, I'm saying that x equals 0, and when I look at point B, x is positive 4. Now what they want me to do is they want me to test this to see if it works. So if we take a look here, if I plug in and substitute in 0 for all my x values, I'm going to have a 1/2 times a negative 2 cubed, which is 8, plus 1, equals negative 3, because these all become zeros. So 1/2 times a negative 8, sorry, that was a negative 8 there. Negative 2 cubed is a negative 8. 1/2 times negative 8 is a negative 4, plus 1, and I get negative 3 equals negative 3. That works out. If I once again try this with the value of 4, so let me go back and get rid of all this here and take a look at what happens when x is 4. So I plug in a 4 there, a 4 here, and a 4 here. Now I have 1/2, and I have 4 minus 2 cubed, which is again going to be 2 cubed, which is positive 8 this time, plus 1. Now I have 2 times 4 squared. 4 squared is 16, times 2 is going to be 32. Negative 6 times 4 is minus 24, and then minus 3. So here I get 4 plus 1. On the other side, 32 minus 24 minus 3 is going to end up being 5, and I get 5 equals 5. So testing them both, 0 and 4 both work. Now we're looking at problem B. Are there any solutions that don't appear on the graph? Well, taking a look at this problem, I have g of x as a quadratic and f of x as an exponential. Or not an exponential, a cubic, I'm sorry. So if I continue g of x this way, it's going to continue rising up like that. However, f of x, being a cubic, is going to rise quicker. So at some point it is going to go up and intersect it again. If you went through and graphed this on your graphing calculator, you'll find out that it does intersect a third time off the graph when x equals 6. So there is a third solution here. Problem C. Now we're taking a look just at f of x, and we want to use point C. Point C, I know that is the coordinate some x value. I don't know what it is, but my y value is definitely 0. It is my x-intercept. So I can solve for x now. So I'm going to have the equation 0 equals 1/2 x minus 2 cubed plus 1. First thing I'm going to do is subtract 1 from both sides. I get a negative 1 equals 1/2 times x minus 2 cubed. I then multiply everything by 2 to get rid of this 1/2 here. So I get a negative 2 equals x minus 2 cubed. From here I'm going to take the cubic root. The cubic root of negative 2 is approximately negative 1.4 0.2599, and that's going to then equal x minus 2. I then add 2 to both sides, and I solve for x to be about 0.740. The very last problem of this is talking about the domain and range. So, taking a look at the domain and range of these graphs, when I look at f of x, my domain is going to be all real numbers. I can go in the x direction either way, and I will get an output. So all x values will work. I also can take a look at my range, and all y values will work for that as well. So f of x has a domain and a range of all real numbers. When I look at g of x, the domain for that parabola is going to be, again, all real numbers. However, the range is not going to be all real numbers. The range has a definite lowest point. So that point right there is the vertex. I can figure out that vertex. It is at negative 7.5. That is my y value for the vertex. So that is the lowest point. So I have y is greater than or equal to negative 7.5.